Good morning or good afternoon, everybody, depending on where the world you're dialing in from. And welcome to our latest webinar called Network Lighting, Stay Connected to Your Security. Hopefully at the end of this you'll have a bit of a glimpse of the direction of travel, the way the industry's going, the way that we see the future of lighting for video surveillance. And I hope it is very much worth your while. My name is David Lambert and I'm the Joint MD here at Raytech, based in our headquarters in Ashington, UK, and I'll be hosting today. Just a couple of housekeeping points before we go on. There is a toolbar as you log into the webinar, and there are 3 or 4 different ways to ask questions. I will run through the webinar. It's a fairly short, punchy webinar. We want to get our main points across quickly, and it should take about 25 minutes. At the end of the webinar, there's a chance for a Q&A session, and there are a few different ways to ask your question. You can click on the Attendees tab and raise your hand, in which case I could unmute you. You could ask your question in audio for the benefit of the whole group, and I can answer to the best of my ability. Puts me on the spot, so very exciting if you want to try that. You could also click on the Questions tab and type your question in there, or you can click on the Chat tab and put your question in there. And I'll review all those areas at the end of the webinar. Okay, so just to go through it, quickly run through the agenda of what we'll cover today. We'll go through our connected world and why connectivity is such a major talking point for everybody at the moment. What connectivity means for lighting. In particular lighting for video surveillance. And we will cover the main benefits of 2 things really. We'll cover the benefits of lighting for video surveillance in general, the very, very basic benefits, and we'll cover the specific benefits of network lighting, so benefits that only network lighting can offer. Look at 1 or 2 practical applications to share with you the way that some of our customers are already deploying network lighting, and probably for me the most important thing is the trends in network lighting today and the way that we see the future of network lighting developing, because that ties in with our vision of the security market generally. Okay. So, our connected world and why connectivity is such a big hot topic. The world, hopefully nobody has missed this, the world is becoming more connected, and connectivity is shaping our world. Devices talk to each other. We talk to our devices more often. I don't know if you've ever lost your cell phone or your mobile phone or left it behind, but you suddenly feel very naked without it because you're relying on it for so many things. At home, you now have connected to so many devices, whether it is your heating, whether it is your thermostat, whether it is window shutters, whether it is your lighting, the color of your lighting. All of that can be controlled through a smartphone or a tablet or something like that. I don't know where this image comes from, but it does also indicate they can control the plug that a hair straightener would go into as well. A trend for they've made a bit of a splash ring with their video doorbell, so if somebody enters your house and leaves a parcel, you can now see who it is, what time it was, or if you're like one of my colleagues at work, you can see what time your wife leaves the house and comes back home after a short day at work. But there is no doubt that our world is becoming more connected and more devices are talking to each other, and we are communicating with more independent devices. In my opinion, we see that particularly with vehicles and cars. We see our cars are becoming incredibly well connected. They do a lot of things and we don't necessarily use all of that power. I'm a bit of a car buff myself, and if I look at a car that's 5 or 6 or 7 years old from the outside, the car looks good, the body shape, the bodywork looks good, the engine's probably fine, the emissions are fine, but if I look through the window at the dashboard at a 5 to 6 to 7 year old car, it's the media system that looks very, very dated very, very quickly. And nowadays, your phone is becoming very deeply connected, not just via Bluetooth, but whether it's via Android Auto or the Apple iCar, the Play system that copies your whole device into your car. You get your SMS messages, you can get your contacts, you can also, one of the major functions is Google Maps through your car now. And actually full integration means that the car manufacturers are now pushing you to use Google Maps over the inbuilt sat-nav system. So you can use Google Maps to drive close to where you're trying to go, and following the map system on the infotainment of your car, get out of your vehicle, take your mobile phone, cell phone with you, and continue tracking your journey through the paths or the footpaths. So it's becoming very, very deeply integrated with our everyday device. So what does connectivity mean for lighting? It means 4 or 5 fundamental things, but first of all, it means IP lighting can plug into your existing network infrastructure. So if you have a PoE-based system, you can power the lighting from a PoE-based infrastructure, and you can, if you have an IP-based video surveillance system, you can also plug it into that existing system, because IP lighting is smart and programmable, and it can be plugged into what you have already. It can be integrated with all the devices you have already. You can control it via your VMS. You can control it or trigger it from other devices on the network, such as a video surveillance camera. Analytics on the camera can trigger the light. You can control it from motion detectors, can trigger the light, give a visual warning, and each light can communicate with other lights. So if one light turns on, it can tell other lights to turn on. And groups of lights can turn on together. The other thing to mention is not only can the light take instruction and input from these devices, the camera, the VMS, the sensors, they can also push commands to these devices. So each light is a very, very basic sensor. As one example, has a photocell on board. So when it gets dark, as an example, your light, the photocell on your light, could then tell your camera to switch from day mode to night mode, whatever your preferred settings are, or more simply to switch from color mode to black and white mode, etc. So each network illuminator can communicate with any other network enabled device, two-way communication. Okay. Key benefits of network lighting. So this is the fundamentals about why we see more and more people using network lighting. There's no doubt that the video surveillance market has gone network, and it's exactly the same with lighting. So one of the major advantages is easy setup and commissioning. So you have a very dedicated, you can find your lamps very simply, and there's a dedicated web interface that allows you to set basic parameters for the light from a remote location. You can change the power of each illuminator, because it's very difficult to make a standard illuminator suit every installation point. So you can change the power of each illuminator, you can change the time, program the time it comes on and off. You can even set automated responses to other things on the network. And that saves all installers time and money, because it means when you can fit a light, and then you can do the setup remotely at a later date. You can commission the light at a later date. You can also control from a central point not just one light but multiple lights. So if you want to set up the whole system, you can do that remotely. Very typically on a large project, we do see setup and commissioning being two separate things, but now it saves all of the commissioning effectively. You can do that at any point during the setup of the system, and it also means that setup becomes a one-man job or a one-lady job from the control room or anywhere in the network, rather than having guys up the ladder, one guy at the bottom of the ladder, one guy at the top for health and safety reasons. So you save half your labour force, you save time, you don't have to do it during the night, etc. One of the major advantages ongoing as well is you can have a remote health check. So you can have a diagnostics feedback of all your lights, so they can be fitted, and as you go to commission them, you can just check that each light is operational, it's all working as indicated, and everything is good to be signed off and handed over to the end user. Okay. Other advantages, you can take live, so except from easy setup and commissioning, you can also take live control over lighting. As I mentioned, normally when you buy an illuminator, they have a distance rated or subscribed to them, 50 meters, 100 meters, 300 feet, whatever it may be. And then you can never have the best optimum light conditions everywhere within that 100 meters, 300-foot range for every event that may happen. An event could happen 95% of its maximum distance away from the illuminator, or 5% maximum distance, so close or far. It could be a highly reflective object or a non-reflective object. So there are times when you need to take live control over your lighting, to tailor the lighting to give you the best results possible. And this is an example of a vehicle pulling up to a gate, and you may want to have a look at the driver, and that was what was possible with the basic setup, and with a little live control of the lighting, we were able to produce a fantastic facial image of the driver. So chalk and cheese, one picture, much better quality than the other picture. Because ultimately in the security industry and the security professionals, we all should be concerned with the quality of the images and the quality of the information we're gathering. And if taking live control or tailoring your lighting to each situation is a guaranteed way to give you better picture quality. This is another example of what you may do to a car pulling up to a gate. You may want to then take live control of your lighting and turn the white light on to allow a security guard to go and investigate the incident, or turn lighting on for other key personnel. It could even be turning lighting on to allow someone to walk from the vehicle to the entrance of the building safely. So, easy setup and commissioning. You can take live control over your images for higher quality pictures. The third major advantage is you can integrate network lighting very intelligently with everything else within your security system. And what that means is you can automate your lighting. So rather than taking live control to deliver better pictures, you can automate your lighting on presets or events or alarms, either from the VMS or from the camera or video analytics or PIRs or motion detectors, whatever that may be. And you can integrate it with anything else on the system. You can also then group lamps together. And this is an example where you might have lamps along the perimeter. The fence line detects a motion, and then an alarm is triggered. From that alarm, you might have the infrared here, and it illuminates the full area. So you see the intruder approaching the fence line. Your infrared is watching the intruder approach. The alarm can trigger then deterrent lighting, and white light can turn on and flash. And unless the intruder's incredibly stupid, he knows he's being watched, then it's triggered a response from the security system on site, and the end user is happy because that intruder has been deterred and turned away. So you can start to automate responses to get the required security results that you want. Prevention of crime, better images, things like that. Just to run through two quick examples of the way that we see integrations happening today. And this is a very basic integration, but it's a fantastic example. And this was done for a network rail project in Australia. And they had cameras here monitoring trains as they came past. But it was a low power installation where they didn't want power to be used by the camera and by the light all of the time. So what they had is to use very low power. They had the audio recording on the camera, and an incoming train was detected on the audio, so the sound that the train would make. If a train was detected, the camera would turn on and start recording, and the light would turn on and provide light. And that integration between the camera and light was a very simple two-way communication done via HTTP commands. So very simple. It saved on energy costs, it produced better pictures, and it integrated the system. So a nice example of a basic integration. A more complicated integration, well, really it can be as deep an integration as possible. It can be as deep as your thoughts and communicate with any other device in the system. We do have an API available for very deep integrations with third-party devices, and we do have a number of off-the-shelf integrations good to go with the likes of Milestone and Genetec and Avigilon and Axis and people like that. But the possibilities are endless. And this was an application where, rather than using an off-the-shelf VMS, there was one of our installers was producing an overall package for VIP end users, so very wealthy, high net worth end users who had a lot of assets to protect. And they basically developed a building management system for the end user. And in that BMS system, there was a security component to it. And the security component involved the cameras and detectors and infrared lights and white lights all talking together. And you had sensors attached to the building. The infrared was always on to support the camera, so the camera could always see who was around the building, but you had sensors attached to the building that when somebody got close, it triggered a white light response to warn the intruder. And all of the cameras and all of the settings to the lights could be controlled through a central building management software that also controlled the end users' heating and other facilities like that. So it was a very smart system. Okay, so that's the main benefits of network lighting and connected lighting. Just to cover some of the core benefits of lighting, just 2 or 3 slides. Core benefits of lighting. This image may look okay. There are 2 images here taken with a very high performance low light camera. We test low light cameras a lot because a lot of the high security projects use high performance cameras, which happens to be the low light cameras. The image on the left is taken without any IR on, and the image on the right is taken with the IR illuminator on. You can see some differences in the image. You see the shadow is here on this image. You see the shadow from the IR is stronger, because you can tell the light from the IR is stronger. You can see more reflection here from the IR. But overall, if you were to look at this image which is without any dedicated surveillance lighting, you may think that is acceptable. But you're not trying to get an acceptable overall image of the scene. You're trying to produce the best possible images for video evidence. And then zooming in, you can really see the difference. So if I go back, you can see the subject here and here as an example. And that's what you get with no light on. That's what you get with lights on. So you always need professional lighting for high performance. You can get away with less or no lighting if you want to see some image, but if you want to use it for evidential purposes or security, you would always need lighting. A modern trend we're seeing is less street lighting available, certainly in the UK. So we would tell people to prepare for dark streets. I have 2 children, one of whom is, the youngest one is 2.5, but I distinctly remember a 1.5 years ago driving around at night with him in my car, 2 o'clock in the morning, and all my local streets were dark, jet black dark, because the street lighting had been turned off completely at 2 o'clock in the morning. So there is a modern trend for local authorities as they move to LED lighting, so there's less load on the overall power network. They drop the light levels during periods of less demand. So past 11 p.m. they may drop the light levels to 30–40% of max. 2 o'clock in the morning when I'm driving around with my child in the car, they may turn the lights off altogether to save on electrical costs, because it costs huge amounts of energy to illuminate the streets at night during, say, the hours of 2 o'clock and 5 a.m. When nobody is really using the roads. So although you may have a video system that produces some image, bear in mind that there is a modern trend to turn off street lights and reduce them at night more and more. At Raytech, I don't know if many people have heard about our power standard, but we do have test data for all of our lights, a recommended minimum spec for any illuminator installation, whether you choose Raytech for your provider of choice for an illuminator or another. We have the power standard that helps you evaluate illuminators for power, overall power, width, environmental standards, etc. And part of that, we recommend the minimum light level on scene to produce good pictures. And that is a scientific benchmark line in the sand. So no longer do you want to hear illuminator manufacturer A saying my light goes 100 feet, and then illuminator manufacturer B saying my light goes 100 feet, but nobody tells you what power they put on scene at that distance. All of our illuminators produce 0.35 microwatts per centimeter squared on scene for infrared, and a minimum of 3 lux for white light. So there's a line in the sand there. And those power levels are based on a medium performance camera and lens setup. Just touch on this very briefly. So our core power levels on scene are 0.35 and 3 lux, and that is based on a medium performance camera. So here's your line 0.35 for infrared. So as your power on scene drops, this is your 0.35 level, so it will cover, let's say, 135 meters with a medium performance camera. If you're using a low light camera or a high performing camera, you don't need 0.35, you might only need 0.3. And in which case, this same illuminator would cover 150 meters. So it is camera dependent, but all of our distances and power levels are based on a medium performance camera. If you advise us of what camera and lens you're using, we would be able to tell you whether you'll be able to exceed our specifications or not. So this is the bit I really want to share with you. Latest trends in network lighting and the way that we see the future going. Trends in the connected world. Just for the technical geekies out there amongst you, of which I am one. This was the launch of the iPhone 8, and originally I wanted to include all of the sensors that were in a modern smartphone, but it is absolutely ridiculous and impossible to portray them all. So I thought I would just take the top display of the iPhone 8 and just share the number of different sensors and input devices in there. You have an infrared camera here. This is a flood illuminator, and I'd just like to point out that is an infrared illuminator that every iPhone goes out with. And that is because they have done away with the fingerprint unlocking, and they're now using facial imaging and biometrics, and they can't guarantee the quality of light when it's checking your face. So there is always an infrared projector shining on your face to check your facial features. Proximity sensor, ambient light sensor, tell you how light or dark it is. Speaker, microphone, front camera. Dot projector, so that's a structured light to shine over your face. And really what I want to share is how many different sensors or devices are involved in just that very top part of the display before you get into GPS and you get into rotational devices and things like that. And it's the same in the motor vehicle world. So this is some of the sensors you may get in your average motor vehicle: parking assist, tire pressure monitoring, speed sensors, drowsiness sensors, seatbelt sensors, radar proximity sensors in front of the car. And both of these slides I just wanted to share with you to say that modern devices include so many technologies and sensors that can communicate with each other and external devices. It's incredible. Now, when you go to buy a car, or when you go to buy an iPhone, you don't get to choose whether you want the dot projector. You don't get to choose whether you want the flood illuminator or the proximity sensor. All of that functionality is inbuilt, and it's likely that most people only ever use 25, 30, 40% of it. It's exactly the same with the car, but it needs all those sensor inputs in order to talk together and talk to itself. And some of those trends we're certainly seeing in network lighting. So the basic trends that we're seeing today can be summed up with these 5 points. There's an increased power of LED illuminators, and that is now affecting everything from your smartphone, car headlights, street lights, everything. So LEDs are producing more and more and more power, and that is going up and up and up all of the time. Our Vario 2 illuminators produce up to 200% of the power of Vario 1 illuminators. That increase in power relates to a huge increase in distance. So the same illuminator, if you buy the same spec illuminator from Raytech today, it will deliver significantly more distance than it would have done 2 or 3 years ago. And that is a performance creep. It's going significantly up. That then transfers itself to savings, because if you need to cover 100 feet and you bought a 100-foot illuminator 2 years ago, it doesn't mean you're happy buying a 200 feet illuminator today, because it goes twice as far. It's likely that you would choose the next model down in the range, because that is now improved, so it now also covers 100 feet. So because the power has gone up, the distance has improved dramatically, it means you can now use a smaller device to provide savings on the overall lighting infrastructure on site. There's more features in every single illuminator, because each illuminator now effectively is a mini computer. It has its own microprocessor. It's part of the network. It can make more decisions. There's more features. It can communicate with more things. And more and more illuminators are becoming PoE standard because it has to fit into that existing network infrastructure. So they are the very 5 basic fundamental building blocks in today's network lighting. And the way that is transferring itself to products in the market is we are seeing an increase in devices that have more functionality. So, for example, we would now put infrared, and there's a 24 LED infrared illuminator here, a 24 LED white light illuminator, then add network connectivity, IP control, add PoE power input, and that is all of those 4 things are now represented in the Vario 2 hybrid. So the eagle-eyed amongst you will see that whereas there are 24 infrared LEDs in the Vario 2 I8 and 24 white light LEDs in the Vario 2 white light, the W8, there are only 12 of each here. But with the hybrid, we can pack more power out of it and we push more power out. So this product does what that does what that does, and its IP and its PoE. And I want to talk less about this product, it's more about the general trend. There will be a general trend where each illuminator does far, far, far more than it's ever done before. So you will effectively get white light for free or virtually free. You may not want to use it, but it will be inbuilt there as free so that there's more functionality and smarts inbuilt, more scalability in any system. So you can install infrared today, and if the end user wants white light on, in the future you can turn the white light on. It will not mean a significant increase in costs. Please do not think that. It wasn't like that with cars or phones. There was just a technology creep. If we start to standardize on better base equipment that has more features and functions, it means we can really work hard to drive the cost base down in those core components and standardize on parts. As an example, this was an installation, it's a pretty old one now, 5 or 6 years ago, all around the perimeter of a power station in the UK. Every camera has a white light illuminator, a big one, because the white light used to be less efficient, less powerful than infrared, and an infrared illuminator. The same kind of application today, it just needs a single panel illuminator that produces both white light and infrared. So that's the way that the market has moved and is moving. If I was specifying, and I do often specify lighting, I would always be specifying hybrid IP PoE lighting now, because that's got all the functionality and it's not, well, if it's 2 or 3% more expensive, that's about as far as it will get. So the future of lighting, the future is very much connected. Everything is connected, even your TVs are now connected, your smart TVs at home all have apps on and talk to other devices. Amazon Echo is making a huge splash, but it'll microphones, speakers, reading your power, proximity, health, heart rate monitors, etc. So the future is very much connected. In terms of lighting, lighting is connected, and today, this is everything I've been talking about today, PoE, IP, hybrid, network. In the future, we'll continue to add functionality into our signature devices. So you'll have temperature monitors, you'll have feedback from the system on temperatures that may want to tailor to your lighting. Every light would be increased vandal resistant, every light would be vibration resistant. You'll be able to change your angle of the illumination on the fly remotely, either from live control or through the system. Increased salinity test. So basically the way that we see the future of the market going is each light will do more, offer more, and be spec'd higher. At the moment, I think that Raytech offer more different illuminators than Apple offer smartphones, which is relatively scary when we think about it. In the future, we'll still offer a broad portfolio of illuminators, but the signature devices will do everything at a base level cost. So that's the seminar for today.